And now for an example. A ball is thrown with initial speed 40 meters per second at an angle of inclination 30 degrees from a point that's 25 meters above the ground. Let g equal 10 meters per second. Now, before I even read on, I can see there's going to be a lot to do here. I'm going to need to think about that initial condition, a quick sketch, and then find my 6 equations of motion. Then from those, I'll be able to answer any questions that come after. So just a general idea here of where to put my origin. We want to put our origin at the point that the ball is leaving from. That means that the ground will be at negative 25. And if we do that, it just means that our constant of integration will be 0 for x and for y. So that sort of makes sense. So a quick sketch here showing where the origin is and that the ball is leaving the origin and going out to the ground, where the ground is actually at minus 25, reminds me of what I'm doing. And then a quick sketch of the initial velocity. It's 40 meters per second, but it's headed off at an angle of 30 degrees. So that means I can look at the initial x dot and y dot here, and I can see that the cos of 30 degrees is going to be x dot over 40, and the sine of 30 degrees, is going to be y dot over 40. Now to make my 6 equations, always start with this one. Now we can see that to get the initial velocity, we need to integrate that. Now, technically here you should write that it's a constant and then say what the constant is. You don't necessarily want to jump straight into just writing the equation because you need to show how you got it. So we've got a constant, let's call it C1, and we can write that when t equals 0, x dot is equal to, what have we got here? It's 40 times cos 30. That's 40 times root 3 on 2, which is 20 root 3. So you can do that working in your head like I just did, or you can write it all out, completely fine. I'm a bit short on space, so I'm doing some things in my head. So therefore what I've just found is that C1 is 20 root 3. So therefore I've got x dot is 20 root 3. So I'll just put a box around each of these as I get to them. And now to find x, I need to integrate that with respect to t, which means I get 20 root 3 t, plus c, let's call this C2 because we've already used C1. Now, what is C2? Well, when t equals 0, where did we start? What was x? It was 0, wasn't it? So x equals 0, therefore C2 equals 0. So we've just explained what we've done so that now we can say x is equal to 20 root 3 t, and we know that C2 is 0, so we don't need to add it on. Nice and simple. Now our y formulae, we are going to start with negative 10 because we've been asked to use that. So that means that we need to integrate that with respect to t, which will give us negative 10t plus c, we need to use c, what have we got, 3 now? Now, what's C3? Well, it's what this was at the start. So we can jot down when t equals 0, y dot equals, it's going to be 40 times the sine of 30, and the sine of 30 is a half. 40 times a half is 20. So therefore, C3 equals 20. Put a box around that one. So now we can see that we've got minus 10t, and this value here is plus 20. So that's fairly straightforward. Oops. And now we need to integrate one more time. Y is equal to, now we need to raise the power by 1, so that's going to give you a t squared. But you need to divide by the new power, and minus 10 divided by 2 is negative 5. And then we need to integrate 20 with respect to t, which gives us 20t, and we need to add another constant, let's call this one C4. Now, when, oh, sorry, it's getting a bit messy over here. When t equals 0, y, we decided we were starting from the origin and calling that 0, and that the ground is minus 25. So y is equal to 0. Therefore, C4 is 0. Sorry, that's a little bit messy there. So now we can rewrite y, it's minus 5t squared plus 20t. So you can see there that by having our ball leaving the origin, it meant that both of our constants here were 0, which meant that these formulas were nice and straightforward. Now I think I'll write these at the top of my page and just rewrite the things that I'm really going to need so that I can answer these questions here. Okay, now I've got my 6 equations up here and I'm ready to answer part A. Find how high the ball gets above ground, how long it takes to get there, its speed at that moment, and its horizontal distance from the start. So I'm looking at that point where the ball has reached its zenith or its high point and it's about to start going back down again. Now, if we think about our horizontal and our vertical components of velocity, the ball's still moving forward at that moment, but it's not moving up anymore. It's actually reached its highest point. So that means that we need to let y dot, that is the vertical velocity, equal 0, because it's not going up. And when we do that, we're going to be able to solve it for t. So that tells us when it's going to happen. Now, if we want to find how high the ball has got above ground, we'll need to look at the formula for how high it is. Remember, this formula is how far out is it? This formula is how high is it? This one and this one are the horizontal and the vertical components of the velocity, and these are the acceleration. So keep it really straight which formula you need for what. So we need to let y equal 0 and find t. Sorry, y dot equals 0. So we've got this formula here, minus 10t plus 20 is equal to 0. So 10t is 20 and t equals 2. So therefore it happens after 2 seconds. Now we haven't been asked that, so we're still on the path towards one of our answers. Find how high it gets. All right, when t equals 2, after 2 seconds, how high is it? Well, what's y at that time? It's going to be negative 5 times 2 squared plus 20, lots of 2. So we've got 40, and this part is 4 minus 20, so we've got 20. Now, that's 20 meters above where it started, because remember we let our origin be the point where the ball left. So to find how high the ball gets above ground, we need to really consider a little sketch here, that our origin was here, and the ball is going along like that, and that the ground is at minus 25. So we've just found that this height here, it's got 20 meters higher than it was. So total height, or highest height, would be a nice way to put it, is 45 meters. Okay, there's one of our answers. Now, how long did it take to get there? So we found that. It's reached after 2 seconds. So make sure you write your answers out so that they're very clear. Perhaps we'll put a box around the things that we found. Total height is 45 minutes. It's reached after 2 seconds. Now, what is its speed at that moment? Now, when you're asked about speed at a particular moment, you need to use both of these formulas here to consider the horizontal component of your velocity and the vertical component of your velocity. Your speed will be the hypotenuse. But in this example, notice that we've already considered that we are at the very top of the flight. So in fact, we won't get a right-angled triangle because what we've acknowledged is that after 2 seconds, we don't have any vertical velocity. It's not going up anymore. So that means all of the velocity or all of the speed is contributed by the movement forwards. So it is going at 20 root 3 meters per second at that time. And lastly, what's its horizontal distance from the start? So in other words, when t equals 2, where is it this way? So how far out is this? We're finding this distance now. So we've got a formula here for x. So we just say when t equals 2, x equals 20 root 3 times 2, so it's 40 root 3. So therefore 40 root 3 meters horizontally from start. Okay, so make sure that you're actually using worded sentences, so we can put a box around each of the things that we've found so that it's really clear where all our answers are to that first part of the question. All of that was A. Now I'm going to get rid of that, so get it down if you haven't yet, and let's have a look at B. For B, we need to find the total flight time, the horizontal range, that just means how far does it go altogether, and the speed and the angle at impact. All right, so the total flight time. Now, we can see that the ball is going to stop when it hits the ground here. So thinking about what we know about that point, we know that at that point, we don't know x, but we know that y will equal negative 25. So let's write down, let y equal negative 25 and find t. So we need to start by finding when it happens. That will tell us how long the ball's been going for. So negative 25 is equal to negative 5t squared plus 20t. We can get everything onto one side here. 5t squared minus 20t minus 25 is equal to 0. and we can divide everything by 5. That will make our life a lot easier when we're factorising it. So I can see here that we need, what is it? We need 1 and 5, and we need it to be +1 and -5. So then t equals -1 or 5. Now, time equaling -1 is not valid. We're not going to go back in time. Technically, what we've found is that there's a 0 over here, which is not relevant. So t is greater than 0. Therefore, t equals 5. All right, so the total flight time is 5 seconds. We can write that down. Flight time equals 5 seconds. That's our first bit of information found. Now, the horizontal range, well, that just means we're trying to find what is x when t equals 5. So just literally write it down. When t equals 5, x equals, and here's our formula, 20√3 times 5. Now, I haven't written it down like that because I can't do 20√3 times 5 in my head. I can. I've written it this way because I've been really clear that I've subbed in 5 for t. So that if I make a mistake somewhere along the way and one of my formulas isn't right, they can at least see that I've used it correctly and I can get some marks for that. So x is equal to 100√3. So we would say range, the horizontal range, range is 100√3 meters. That's our next piece of information found. Now, the speed and the angle at impact. We know when impact is. It happens when t equals 5. So to look at the speed then, now we need to look at the two components of speed and draw ourselves a little right angle triangle. So as the ball comes down and hits the ground, what we want to find is this angle here. We know that t equals 5. So x dot at that time will be 20√3 because it's that the whole time. So this is 20√3. And y dot is going to equal, when t equals 5, minus 10 times 5, that's -50, plus 20. So it's going to be -30. Now, velocity being negative, what does that mean? It means the ball's going down. So that makes sense. Does that mean that we should label this -30? No. I think 30 will do here because we're actually just trying to find the length of this hypotenuse here. And when we square this, it's not going to make any difference whether it's -30 or 30. So Pythagoras' theorem can help us find the speed at that time. Or we could use trigonometry and say, once we've found the angle, because the angle is something we need as well. How do you want to do it? Take your pick. We'll put -30 in there. Let's go for Pythagoras and say speed is going to be equal to the square root of 30 squared plus 20√3 all squared. Now, when you've got something like this, if you put it in your calculator, you're going to get some nasty decimal come out. And perhaps the question will be okay with that. They might have specified how to round your answers at the start. But if you want the chance to still work using exact values, a little tip, put this part into your calculator, not inside the square root bracket. Then you're going to get here the square root of 2,100, which I can see is the square root of 21 times the square root of 100. So I'm going to get 10√21, which is a nicer answer, I think, because it's exact. So that goes here now. So speed, I can actually just put that in here, meters per second. That's another thing that I've found. And now I can find the angle, and I'm spoilt for choice. I've got 3 sides here to use. So let's go tan of theta equals 30 over 20√3. So theta will be the inverse tan of that. Let's make it a little bit simpler to put into the calculator. 3 over 2√3. Now, in exact form, that's as good as that can get, but we can put that in our calculator and come up with an angle to the nearest degree. 2√3 equals, and we've got 40, let's say 41 degrees. It's roughly equal to that, to the nearest degree. And your question will normally specify how they want you to round things off. And working in exact values is not essential, but it's kind of nice if it's easy to do it, especially if you're going to use that figure later on to figure out something else.